this time, and we're gonna rock and roll. So again, section number 1, I'll start right away. When we're simplifying our radicals, we're gonna always look for the perfect square that divides in evenly. In case you don't recall or you need another list of them, here are all of your perfect squares. Again, I give you guys up to 100, but if you need to go past 100, you can do that as well for yourself. So that's really up to you how high you want to go. When we simplify, we write as 2 radical 2, and I'll circle the final answers just so you guys are aware. For number 2, we're going to have the square root of 4 times the square root of 6. Someone did email me and said, does it matter what order I put my my perfect square or my non-perfect square? The answer to that is no. The reason why we tend to want to put the perfect square first is because it then is easier for us to just say, okay, so the perfect square is 4, and when we take the square root, it becomes 2. And so there's not really any more work we need to do regarding that. So when you write this down, like for the next one, 99 has a largest perfect square of 9. And so when you write that down, you would simplify to 3 radical 11, and now you have the radical part after the whole number part or the rational part. Last few, sorry, you know my hand hits this all the time. So we have the square root of 4 times the square root of 15. Again, you'll start to see some repetition in your numbers, and you'll know that you are simplified if the radicand, definition of the radicand is the number that's underneath the radical. If the radicand is not going to simplify any further. For the next one, the largest square would be 16. And we end up with -4, the square root of 3. And the last one, the largest square, this one should be pretty obvious, is 100. We end up with 10 times the square root of 3. Okay, so there's your first section. If anyone needs some time to make corrections, and if anyone has any questions, and if not, we'll go to section 2 in a few moments. And I'll just start talking about section 2 in a moment. But again, you guys know, just raise your hands. I can see you on the side if any of you have any questions, and I can definitely address those. When simplifying radicals that contain variables, remember that even exponents will be perfect squares. So I'll write PS for perfect squares. And if it is not even, such as an odd exponent, you will lessen the exponent by 1. And the reason being is because we cannot simplify some variable raised to the first power. And then when we lessen an even by 1, we create an odd. So for example, in part 2A, lessening the 44 by 1 gives me 44 and 1 as my exponent, so it's still equal. But remember, to take the square root, we simply divide the even exponent by 2. So the square root of 8 to the 44 would be 8 to the 22 times the square root of a. And if it is already even, then you would just go with dividing by 2 right away. So ask yourself, can I divide my exponent by 2? If I can, great, it's a perfect square. And if I can't, then I need to figure it out from there. We are going to then simplify the next one. So we would break this up into components. I'll tell you, if this is a way that helps you, go for it. If you can do it in less steps and you feel comfortable, go with that as well. So we're going to get the square root of 16 as the largest square in 32. We're going to break a to the 7 into a to the 6th and a, and then b to the 4 is already a even exponent. So we're going to get, now here's another thing that you can do. You can start to write your answer. Let me do it over here by writing all the perfect squares first. So what I mean by that is 4, from a to the 6th, we get a to the 3rd, from b to the 4th, we would get b squared, and then the 2a would just be placed inside of the radical. So if you can do this in less steps, what tends to end up happening is we tend to, just speed up our process and save ourselves time for other examples. With the square root of 33, that is not going to simplify. There is no perfect square divisible. Radical m is the same deal, but n to the third would be broken into n squared and n. So the only perfect square that we have in this example is n squared. So that would be the n, and we would be left with 33 mn as our simplest form. For the next one, 80, and again, here comes that repetition. We're going to have 16 and 5. So this is what I mean by saving yourself time. For the square root of x, that's going to stay, and then y to the 5 would become y to the 4 and y. All of your perfect squares, 16, x to the first will not simplify, y to the fourth will, it would become y squared. So you've taken care of this one and this one, and what remains will go inside of the radicand. And so our final answer there, negative 4y squared, the square root of 3xy. And then I meant probably for this one to be over here, so it's the same one. So I'm just going to simply get rid of that one. So I'll give you guys some time to catch up on anything you need there or ask any questions. And then we'll move to our third set. And by the way, I just want to reiterate that if you don't like doing what I just showed you, meaning you don't like doing it in less steps and you need more, go for it. You have as much paper as possible to show your work, so please consider that. Okay, so I'll just take a pause for you guys. Yes, and Zelha?
Hi. In a D, it's a 16 to 3 or 16 to 5, like when we divide 80.
It's 16 times 5. I wrote 3. I always can't see on this iPad well. 5 it is. Thank you. So it should be 5xy. Thank you. This looks like a 3 to me. I should make it look more like a 5. Thank you. Okay. For the third set, we're now going into the operations. So we're going to start with addition and subtraction. The rule here is to simplify first and combine later. So in this case, these cannot be simplified. However, they are the same radical. We get 6 radical 2. I'm just not going to circle here because it's getting a little messy on me. For the next one, we have all radical 5s. So 9 plus 8 would be 17. 17 minus 16 would be 1 radical 5. You're not going to see an answer written like that. So you would just pick radical 5 as your answer. In terms of showing work, many of you ask me, if I do this or that, and that's totally fine. You can always check in. But what I will say is, you should know when it's appropriate to show work. So if work can be shown like in the next 3 examples, that's what we expect to see. For the next one, 40 would be broken into radical 4 and radical 10, which would be 6 times 2 radical 10. And obviously radical 7 cannot simplify. So 12 radical 10 minus radical 7 would be the answer. I guess I should box them in. And you guys should really box in your work for yourselves as well. The next one, 12 radical 5 will stay. The largest square in 45 would be 9, and the largest square in 80 we just spoke about a moment ago was 16. This is going to be 12 radical 5. Now here's where you can be a little bit more mental with your math. 3 times radical 9 is the same as 3 times 3, which is 9. Same thing here. This is going to be 12 times 4, which would be 48. Okay, so again, you do as much work as you need, but obviously we can see that you understand that going from 12 radical 16 to 48 was the multiplication by that perfect square's value, which is 4. These all have radical 5, which is great. So we're going to get 12 plus 9, which is going to be 21. And 21 minus 48 would give us negative 27, radical 5. The last one definitely has some nice simplifying going on. So this would be 3 times radical 4 times radical 2, which is 3 times 2 or 6 radical 2. The next one would be 5 times radical 4 times radical 5, which is going to be 5 times 2 or 10 radical 5. And the last would be radical 100 and radical 5, which is going to be 2 times 10 or 20 radical 5. Now this 6 radical 2 will stay as is since there's no other radical 2, and the 10 and the 20 being subtracted would give us minus 10 radical 5. Okay, so there's part 3 if you guys need any time to catch up. Okay. And again, just to reiterate, this is all being recorded, so you can always go back and rewatch it as well. Okay, so going in the order that we discussed our topics for radicals, we did simplifying so far. We did simplifying with variables. We just did adding and subtracting. And the last 5 sections are going to be multiplication. Now for the section 4, which we're looking at right now, these are all monomials, and I'm going to just make a little note of that so you can tell the difference in the procedure, as you guys go through your steps. Starting with the first one, we multiply first and then we simplify later. Although radical 9, you could just write as 3 radical 2. So I want you to understand, especially with today's lesson, that if you see something one way, as long as it's mathematically sound, that's okay. So this 3 came from the square root of 9, and then the radical 2 just stuck. If you're used to multiplying first and you wrote radical 18, and then you wrote radical 9, radical 2, you might have realized it after, but regardless, we get the same answer. Indira?
Do you want us to turn it into a decimal after that or
No. These are all going to be written in simplest radical form. Plus, we're not supposed to be using calculators in this class. So the only way you would know how to do decimal from a radical would be through a calculator, which is not accepted in this class. So be careful on that aspect, okay? Everything should always be written in simplest radical form. So what we're doing by simplifying our radicals is creating what we call simplest radical form. So no decimals in any radical situation, at least in this class. The next one, we would simplify to radical 150. The largest square would be 25. And that gives us, again, sorry about that, 5 radical 6. If I move it over, it will work better for me. Okay, notice none of these have coefficients other than 1. That was also very helpful in this process, so I should have pointed that out from the beginning. So we're going to have 14 times 6, which is going to give us the square root of 84. When you start to simplify, you would probably realize that 4 goes in evenly. So we get 2 the square root of 21, no simplifying possible. When we deal with our exponents, I'll just remind you, you're going to add the exponents since you are adding like bases. So we would get x to the 7th power. Because it is not even, we lower by 1. And we get x cubed, the square root of x. Okay, and obviously the more variables we introduce, the more simplifying we will have. Oh my goodness, this thing, I love it and I can't stand it. For our next example, we will get 5, a to the 9, b to the 4. So the square root of 5 will stay. The a to the 9 will be lowered by 1 to create an even exponent of a to the 8th. And then b to the 4th is even. So the perfect squares are a to the 8th and b to the 4. You can underline them. And then the non-perfect squares, which I'll check, are going to be 5a underneath. So that's another thing that you can do if you want to save yourself time. The last one, so if you notice, this would give you the square root of 144, but we did discuss last week that when you guys multiply any square root radicals that are the same, you just get back what's inside, so you can take care of that right from the beginning. We get x to the 6th and y to the 9. So x to the 6th is already a perfect square. Y to the 9 will become y to the 8th and y. So the perfect squares are going to be x to the 3rd from x to the 6th and y to the 4th from y to the 8th. And we would be left with the square root of y. So let me just kind of leave that there. I know you guys might need another few minutes. Victoria?
Professor, could you scroll up a little bit for the part 1 and 2?
Yeah, let me do that after, just because most people are here. So if you don't mind, Victoria, I'll scroll up to the top. This is, I'll also post this, but just give me a few minutes to finish the homework. And then while people are getting themselves situated, I'll do that. If you see I forget, I'll go back up there, but I'll just do that at the end. I just want to keep this kind of moving. Okay, any questions on part 4 before we go to 5, 6, 7, 8? Okay, so I'll give it another few moments. Okay, so in our next part, we're now going to still have monomials, but they're going to have coefficients. So we need to ensure that we multiply the coefficients correctly. So remember the rule, what's outside the radical gets multiplied. So in this case, 2, and then what's inside the radical gets multiplied. And you can write that as radical 9, or notice it just becomes 3 and we get 6. For this one, what's outside the radical first, what's inside the radical, which will just give us 8. And that's going to give us, I believe, 112, excuse me, which is our final there. A quick way of multiplying 2 is you could do 80 times 10, 8 times 10 is 80. 4 times 8 is 32. And then 80 and 32 is 112. The 4 and the 3 will give us 12. The 8 and the 2 underneath will give us 16. That's 12 times 4, which is 48. For letter D, the coefficients become 12. Underneath the radical becomes 75. Sorry, that's 15 times 5, not 15 times 3. Largest square in 75 would be 25. And we end up with 12 times 5 radical 3, which is 60, the square root of 3. Okay, so multiply first, simplify later. Since you have a negative times a positive, you will get a negative. I did not mean to give you 2 examples in a row with radical 75, but I guess I did. So again, we already know it's 5 radical 3, negative 30, the square root of 3. For F, we're going to multiply 5 and 6 to give us 30, and then the radical parts to give us 3. 30 times 3 is 90. And just for the special case of G, with letter G, we know that anytime we multiply something, we square something, we multiply it by itself. So please make sure to do that. I'm telling you, you'll probably see a question like that on my test as well. The 2 radical 5s, the 2 5s in front become positive 25. The radical 5s become 5. And that's 125 as a positive solution. Okay, so I'll give you a couple of moments there. Of course, if anyone has any questions, I can answer them on this part. We're now going to have monomial times a binomial, which means we're going to distribute. And then we have 2 more sections before we move forward. For those of you that feel a little better, if there's no coefficient to put a 1, then go for it. So I would put a 1 here, and that way we would be able to then use that to multiply carefully. So when we distribute, the 1 and the 3 become a 3. And the radical 2 and the 2 become a 2. And then the radical 2 times the 4 is on the outside, the radical 2 is on the inside. We get 6 plus 4 radical 2. I saw a couple of you guys, I was just eyeing the homework over. Some of you feel the urge to try to add the 6 and the 4 together. Please don't do that. You cannot add unless they have common or like radicals. So please be careful. For letter B, we're going to get 8, the square root of 81, which we already know is a perfect square, but we'll deal with it in a minute. And then we're going to get 12 times radical 3 times radical 3, which is 3. So this is 8 times 9 plus 36. 8 times 9 is 72. We should have got 108 there. So if you notice, and I like to bring up the words again, that would be called a rational solution. Rational solutions are solutions that contain no radical at the end. Our next one is going to be negative 40, radical 18, and then negative 10, radical 12. The largest square in 18 would be 9. So that would be 3 radical 2 or negative 120 radical 2. The largest square in 12 would be 4. So that's 2 radical 3 or negative 20 radical 3. And since they do not have the same radicands, the number underneath, we cannot combine them. And finally, for our last one before we pause, we have 8 that's negative, and then the radical 3's become 3. We have the 4 and 4 to give us 16, and then another 81. So I guess I liked 81 in this problem. And we're going to get negative 24 plus 16 times 8. So again, you could do that little trick I showed you. 10 times 8 would be 80. 6 times 8 is 48. So we get 128. And when all is said and done, we are going to get an answer of 104. So if you want to make a little note, B and D happen to be rational and A and C are irrational.
Shouldn't it be 16 times 9?
16 times 9, thank you. I'm a little tired today, not that it's an excuse. Yes, it is. So 16 times 9, you could do the same deal again. 16 times 9, so 10 times 9, I should make a little correction here. 10 times 9 is going to be 90. 6 times 9 is 54, so we get 144. I don't know why I even had that on my notes. I don't know what I was thinking when I wrote the 81. Did I do that before? I did 9 up here and then I did 8 there. I don't know what I'm thinking. 120 should have been our answer. Thank you for the correction, Deanna. Okay, so there is part 5 or 6, whatever it is. We have 2 more to go, and both sections to finish up are both binomials times binomials. So we will use FOIL only in the last part, that is the special case that I want to pay a little close attention to, because we're going to be using part 8 in our lesson this evening in a few moments. So again, I'll just pause for you guys to catch up there. Okay, these are the distributive properties, so we're going to multiply carefully. Radical 3 and radical 3 is 3. Radical 3 and negative radical 7 is negative radical 21. Coming underneath, negative 2 is going to be on the outside, and radical 21 on the inside. And then negative 2 times negative 1 would be positive 2. And the 2 radical 7s become 7. 3, these are going to then combine to a 3 radical 21 and a 14. 17 minus 3 radical 21. If you write your answer as negative 3 radical 21 plus 17, it is the same answer. It's just in an opposite order, so you are allowed to do that. Just be on the lookout for your answer choices. For letter B, same deal. Let me just kind of switch up the colors a little so it doesn't all mishmash together. So the radical 2's will give us 2 with the 5 and 2 giving us 10 in front. The 5 in front will give us 5, and the radical 2 and the radical 10 is radical 20. This is going to be plus 4 radical 20. And this is going to be minus 2 times 10, since the radical 10's become 10. Now, when we simplify this, we can do one of 2 things. We can notice that this is going to be 20, and then this is going to be 20, and 20 minus 20 will cancel. So we're then going to be left with a negative radical 20, since these will combine. Radical 20 can be simplified. There's a largest square of 4. So the final answer there would be negative 2 radical 5. And as I mentioned earlier, your answers, or you will be asked to express your answers in what we call simplest radical form. For letter C, we're going to have a binomial squared. A binomial squared is that value times itself. Okay, and again, we will apply that same property. So radical 5. This is going to be a radical 35. This is a radical 35. And this would be a plus 7. We're going to end up with 12 plus 2 radical 35. There is no square in 35 that would simplify. These are not conjugates. A conjugate pair, again, would have a plus and a minus, and the binomials would be the same. So in the next section, they are, so be aware these are not conjugate pairs. Finally, the last one on this section is going to be the same binomial again times itself. So radical 11 and radical 11 is 11. Radical 11 and 5 radical 2 is negative 5 radical 22. Same deal in the middle terms. And then plus 25 times 2. This is 50. 50 plus 11 is going to be 61. And then we're going to have minus 10 radical 22. Okay, so there's that section. Again, if you want to make a quick note, C and D are not considered conjugates. And in part 8, it is considered conjugates. You know what? Let me write it down here. And I'll just remind you, a conjugate pair is going to be the same binomial. One has a plus, one has a minus. In a conjugate pair, your answer will always be rational. And in a conjugate pair, the middle terms will cancel. So you only, I want to write this for you guys, so I'm just going to write it over here. I'll remind you of all these things after. In a conjugate pair, you only have to multiply first and last terms. If you want to multiply the middle terms, go crazy, but there's no need to do so. So I'll give you a moment to do that or to get that down. We're going to be talking about conjugates a lot at the end of our lesson today, the last half. So you're going to really see a lot more use of this. So it will be very apparent as to how and when to use it. For now, this is a conjugate, minus and plus, same binomials. So radical 7 and radical 7 is 7. 4 and 4 is 16. And a negative and a plus always give us a negative. So the answer there, very easy. And again, remember, rationals will not have a radical in our answer. Negative 9. If you want to work out the middle terms, go for it. It wastes time. And you also are going to see that they're always going to cancel. For letter B, we're going to get radical 5 and 5, which is 25, a negative and a positive. 4 and 4 is 16, radical 3 and radical 3 is 3. We're going to get 25 minus 48. And again, since we do not have any radical left in our answer, we're going to have negative 23, which is considered rational. Radical 15 and radical 15, radical 17 and radical 17, negative 2. The answers don't always come out to be negative. I made a little note of that. Please be aware that the answers are just coincidentally negative in these examples. We will see quite a bit today where they're not always negative. So I don't want you to think that conjugates always multiply to a negative. That is not a correct or a valid statement. So I'm just gonna take any questions. I know there somebody asked me to do the first 2 slides. I'll slide up in a minute. Just a couple of reminders while you guys are getting down your last stuff. So we went over our homework. We're gonna do lesson 12 for the rest of this evening. I made a video. The link was emailed to you guys, but it is on the YouTube page under course information about the review. The review sheet answer key did have a mistake on number 27. I circled the wrong answer, but the work is correct. So I did fix that and post that this morning and email you guys. If any of you at the end of class need me to go over anything from the review, I will. Exam will become available Wednesday from 7 to 11. Remember, I do that as a courtesy. Same deal, 25 multiple choice with work uploaded within 45 minutes. And the final exam, I will remind you every day from now until till the final. When you guys meet me again on Monday, we're not going to have any homework to go over. So I will post lesson 13 and 14. It's the last 2 lessons we have left for the semester, sometime before this weekend for you guys. So before I scroll up, does anyone need me on, or you know what, let me scroll up and then I can always scroll back down. If anyone has any questions, let me know. As usual, I will post this stuff for you guys after class or in the morning. And I'm going to ask you guys to get lesson 12 ready. We're going to get started with division. I think that you guys will find division to be fairly easy. Okay, so I'll give you guys another moment and then we'll do that. And again, if anyone needs clarification and wants to wait till the end, you could always do that as well. Okay. So again, I'll always be able to open that back up. This is our last radicals lesson, and this deals with division of radicals. Now, to be honest with you, there are 3 different scenarios that we will see. That Victoria, I'm sorry. Did you still read it?
Professor, yeah, in part, yeah, the second, the one on the right,
Right? Mhm.
B. Is it not?
That's the right answer there.
I got it. Uh-huh.
Okay. Good.
Yeah, good.
Okay.
Thank you.
You're very welcome. I can pull this back up, Victoria, at the end too. I just want to get tonight going, but if you still need to check on this, just let me know and it's very easy for me to pull that up, and that goes for anyone else as well.
Okay.
Okay, so just stay on at the end and I could pull it up, and I always do post this anyway, but stay on and it's very easy for me to do for you. So there's going to be 3 scenarios. We're either going to see a radical in the top and a radical in the bottom, which is this, by the way, this is the easiest case. Then we're going to see a radical in the denominator. And then we're going to see some radicals in both. And then we're going to have some nasty binomials, and we'll get to where we are right here. So let's start with the easy part and work our way up. What I'm going to do, as I always do with you guys, is I'm going to start to show you, and then I'm going to give you some to try. So I'm going to actually model all 6 of these questions for you. I will talk them through slowly, and then you will have 5 examples where you will have an opportunity to do this without me. So the first rule is, if we can divide the numerator by the denominator easily, we're going to attempt that first. Meaning, if the numerator, I'm going to make a little extra note here. If the numerator and denominator both contain radicals. And if we can then divide easily within those radicals, we're in good shape. So the rule is, and if you guys remember, think about what we were just doing a little while ago tonight. When we had radical 15 and radical 3 and we were multiplying them, we were able to take the 2 separate radicals and create a single radical. And then we were able to simplify from there. Same rule right now. So this radical 40 and this radical 10 can be thought of as radical 40 over 10 like this. And since they're both underneath the radical, we get radical 4, which simplifies to 2. So it's basically the same kind of concept. For letter B, we have 32 and 2 both in the radical. So since they're both in the radical, we can divide them to give us the square root of 16, which would give us 4. Okay. For the next one, we are going to have 30. I should have made that a little bigger. I always do that. 30x to the 2 over 2x to the 1. Again, the 30 and the 2 and the x and squared and the x to the 1 become radical 15x. no simplifying possible there. For letter D, again, and by the way, I'm only writing this to show you, if you want to do it mentally and not write it in this step, you don't have to. But we're going to get the square root of 3x to the, what is that, 9 minus 3? I wrote a 2 on the bottom. It's a 3, which is 3x to the 6th. The square root of 3 cannot simplify, but x to the 6th can, and we get x to the 3rd, the square root of 3. So the simplifying really has to be there at this point. Oops, I'm going to do that a million times tonight. For the next one, again, if you don't want to write out the step, this is what I mean. So you see 75 divided by 3 is 25. M to the 10 and M to the 2 is M to the 8. N to the 9 and N to the 5 is N to the 4. And again, we are only able to do this because they are both in the radical. If one is on the top in the radical and one isn't, which we'll see in a little while, it's a different story. Everything here happens to be a perfect square. So 5m to the 4th, n to the 2nd power. 17 times 4 would be 68. So when we divide, we get 4. 8 to the 9 and 8 to the 4 is 8 to the 5. B to the 3 and B to the 1 is B to the 2. So the square root of 4 would give us 2. A to the 5 would become A to the 4 and A. So that's A squared radical A. And then B squared is just going to be B squared. I'm sorry, it's just going to be B when we take the square root. And so we're going to get 2A squared B, the square root of A, as our answer. Okay, so before I take your questions, as I always like to do, and of course I'll put a little timer on for you, please remember that we like to always make sure that we are looking carefully at what we have in front of us. We are going to divide whatever is in the radicals first, if they both have radicals at top and bottom, and then from there we would simplify. Okay, so at this point, if you guys want to start to do these 5 problems, that's fine. I'm just going to scroll slightly so people can see them. I'll put about 4 to 5 minutes on the clock, but please take your time in working these through, and then we will discuss. So the timer started. If anyone has any questions as you work, feel free to let me know. I am more than happy to answer at this point. Otherwise, 4 minutes on the clock. Okay, you guys, I always like to give time updates. You're about a minute in. About 2 minutes in. Okay, so you're about halfway through. You should be on C or D by now. Okay, so you guys are about 3 minutes deep, so another 2. And as always, if you want to go a little ahead of me, by all means, go for it. If you want to try. Okay, so we're looking at about the last minute to go. Okay, so the last few seconds, we'll get started. I'm just gonna zoom in a little bit here. So I'm not gonna write all of these where they're one above the other in one radical, but you can if you want. So noting that these are both under the same radical, not under the same radical, but they're both under a radical, we would get the square root of 16, which is 4 for A. For B, we would get radical 40, which has a largest square of 4. Final answer there would be 2 radical 10. For C, we would end up with 9. Okay, now you have to be careful about this one. So let's talk about C a little more in depth. So when you're looking at C, and I will set it up this way, you're going to get 15A on the top. I'm sorry, 9A on the top. I cannot divide for some reason. We're going to get 9A on the top. And then on the bottom, you guys are going to get a perfect square, but you have to just be careful. You're going to get b to the 4th on the bottom. And the reason being is because 1 on the top minus 5 on the bottom gives us -4. So we have to put that on the bottom. Now, that's okay. The square root of 9 becomes 3. Radical A will remain radical A. And then the square root of b to the 4th would be b squared. So just be mindful of that one and careful. With letter D, this one will not give us that situation. So 72 divided by 3 is 24. A to the 4, b to the 3rd. We're going to end up with 24 having a largest square of 4. A to the 4th is already a perfect square. B to the 3rd would be b to the 2nd and b. So we're going to get 2a squared b from this, this, and this, and under the radical 6b. Now this one is similar to C, so I'm just going to make a little note so you guys know that it's the same situation. So when we divide 500 by 20, we're going to get 25. A to the 10th and A to the 8th is A to the 2 on top. But then here it is again, 3 minus 5 is going to give us -2, and that has to go in the bottom. When we simplify, we are going to get 5a over b, since they are all perfect squares. Okay, so at this point, please let me know if there are any questions. And then we're going to go into our second piece, which is going to be a little bit more tricky. So I'm going to model a bunch for you, and then you guys will have an opportunity to try some without me. Okay. So now comes the big deal. And this is a rule that if you're going to take a credit-bearing math class after mine, you will see all this. I'm not going to wait for anyone to write this down because it is in the notes, but I will read what's up there. So it says we always want to avoid having a radical in the denominator, especially in our final answer. When we cannot divide easily, we use a process known as rationalizing the denominator. What that word rationalizing the denominator means is to make the denominator rational or to get rid of the radical. So that's kind of the idea, get rid of radical, because as you know, a rational value doesn't contain a radical. For monomial denominators, we will multiply the numerator and denominator by the radical portion in the denominator. When we have binomial denominators, we'll come back to that. So I'm going to stop right here for now with the rules, and we will then revisit this for when we have binomials. So I'm going to model a few problems for you. I want you to understand that what I do might not be the same as what you might do, but I will try to share some different ways of solving just in case. So when we look at A, unlike the last problems we had where we had a radical on the top and on the bottom and we could divide evenly, now we do not. So in A, I'm going to multiply the top and bottom by radical 2 because we are going to multiply by the radical portion in the denominator. Whatever we do to the bottom, we do to the top. Now, why do we do this? Because in the numerator, I don't care if I have a radical in the numerator. That's not my concern. My concern is in the denominator. In the denominator, I am multiplying 2 square root radicals that are the same. And when I do that, I end up with what's inside, which is 2. As long as I do not have a radical in my denominator, it is considered rational. Okay, so normally you can multiply by the radical portion right away. There may be times where you want to simplify first, then rationalize. So in this type of topic, I'm going to be honest with you, there are multiple ways of solving at times. Let me do these 4 just to give you guys more of a sense of what's going on before I take your questions. So same deal, I don't have a radical in the top and bottom that can be divided evenly. So I will rationalize right away using radical 5. I use what's in the denominator. In the numerator, I get 5 radical 5. In the denominator, these are the same, so I get 5. And if I can reduce, I want to reduce. In this case, these are both going to reduce. I can't reduce the 5 in the radical with the 5 that's on the outside, but I can reduce these because they are both outside the radical. And I get radical 5 over 1, which is just 5. As long as I don't have a radical in the denominator, I'm in good shape. Now for letter C, this is where it gets interesting. You are not going to multiply by 2 radical 3. You are just going to multiply by the radical portion, which is 3, radical 3. We're going to get 9 radical 3 over 2 times radical 3 times radical 3, which is 3. 2 radicals that are the same. I get 9 radical 3 over 6. Again, the 9 and the 6 have 3 in common. So I get 3 radical 3 over 2. And yes, you must reduce when possible. Okay, so before I continue, if anyone needs any time to catch up or any clarifying questions, I'm going to answer them. And if not, I'm going to show you 3 different ways of doing D. I'm not going to do this for every question, and I'm going to say if you do a problem today when you're working on your own that's not the same as mine, as long as you get the same answer, you're good. If you want to check with me after class about your individual way, I'm happy to, take that question. But if I sit here and go through 21 people's different ways, that's always an issue. So I will definitely show you, but just make sure you're getting the correct final answer at the end. That's what we're looking for. So again, I'll just give you guys another moment, and then I'm going to show you D, like I said, 3 different ways. So I'll actually kind of like make some space here to show you. I'm not going to tell you which way is right. What I will say, which way I think is the best way. I will tell you they're all going to be okay as long as you're careful. So method number 1 would be to rationalize right away. I would get 4 radical 20 over 20. So the square root of 20 would simplify to radical 4 and radical 5. That would give me 4 times 2 radical 5 over 20. A lot of steps here. This is going to be 8 radical 5 over 20. And the 8 and the 20 have a 4 in common, giving me 2 radical 5 over 5. Sorry. Yes. Okay, so let me just go through it one more time. Rationalizing with radical 20, we get 4 radical 20 over 20. Largest square in 20 is 4. So we get 4 times 2 radical 5 in the numerator. That's going to give me 8 over 20. 8 and 20 have 4 in common. 8 divided by 4 is 2. And 20 divided by 4 would be 5. And I'm left with 2 radical 5 over 5. Okay, that's method number 1. A lot of steps. This would not be my favorite way, to be honest with you. So here's method number 2. Instead of rationalizing right away, I'm going to simplify the denominator first. Now notice A, B, and C, that was not a possibility, which is why I didn't bring it up. But now because I can bring it up, it is a possibility. So the largest square in 20, we just said, is radical 4. I get 4 over 2 radical 5. I'm going to rationalize using the radical portion. So radical 5 top and bottom. I get 4 radical 5 over 2 times 5, which is 10. And I get 2 radical 5 over 5, since 4 and 10 have 2 in common. Same answer, different approach. I'm going to be honest. This is my preferred way of solving. The third and final way, and this is not always possible, and a lot of you might not like this way, so I'm going to be honest and say if you don't like this, it's fine, is to multiply radical 20 by some number that makes it a perfect square. So if I multiply radical 20 times 2, I get radical 2, it's radical 40, times 3 is radical 60, times radical 4 is radical 80, but times radical 5 is the square root of 100, which is a perfect square. I end up with 4 radical 5 over 10, which simplifies to 2 radical 5 over 5. This third way is not always possible. So if I can give you my advice as a, teacher, but also as someone who, thinks, about the easier methods, I like the easy way out too. I'm going to tell you the second approach is personally my favorite approach. So if you can simplify the denominator first, my suggestion is do that, then rationalize using the radical part, and then simplify whatever you need. Okay, so if there are any questions on D, I'm happy to assist. I really still want to show you guys some more problems of me modeling them. So I'm going to keep just showing you. I know you guys want to try on your own, and that's fine. Even if you stick with me, I think the pace is pretty good here. And then I'm going to give you guys some time to try without me. So I'm going to go down to the next 4 problems. Again, I'm going to now get you in that mindset. So for letter E, you're going to see if you can simplify first. You can't. So we will rationalize right away. We're going to get 7 radical 2 over 2. No simplifying possible. Letter F, same deal. I'm going to see if I can simplify first. I can't, so I will rationalize. I get 4 radical 7 over 7. No simplifying possible. And again, as long as I do not have a radical in my denominator, I'm in good shape. Letter G, same deal. I cannot simplify radical 10. So I will rationalize right away. I get 16 radical 10 over 10. 16 and 10 are going to have 2 in common. You cannot touch what's in the radical when you do this. We get 8 radical 10 over 5. And now for H, you can simplify first. And again, I'm going to show you both ways, but I'm also going to say, I'm going to show you all 3 ways for H one more time because I like you guys. So let's start with the first method. The first method that I prefer is you simplify first. So the largest square in 18 would be 9. I'm going to get 21 over 4 times 3 radical 2, which is 21 over 12 radical 2. Now there's 2 things you can do. You can rationalize and then you can simplify, or simplify and rationalize. I'm going to rationalize. So I get 21 radical 2 over 12 times 2, which is 24. So now my denominator doesn't have a radical anymore. 21 and 24 are going to have 3 in common, giving me 7 radical 2 over 8. Okay, so I simplified first, then I rationalized, then we reduced. So that's the preferred method. I'm going to put a star so you know it's what I prefer. Method number 2 would be to rationalize right away. The problem with this method is it sometimes creates some nasty numbers. 4 times 18 would give me 72. I'm going to get 21, and the largest square in 18 would be 9. So as you can see, this method is not my preferred method because I get very large numbers that I have to deal with. I'm not saying it's not doable. I'm just saying it's a lot. I would end up getting 7 radical 2 over 8 when I divide the top and bottom by 9. So I'm going to leave that for you guys to catch up. But again, that's not my preferred method. And then the last example method is going to be to multiply radical 18 by a number that makes it a perfect square. Interestingly enough, when I multiply the top and bottom by radical 2, the square root of 18 times the square root of 2 is the square root of 36. That happens to be a perfect square. It's 6. And then I would divide the top and bottom by 3, giving me 7 radical 2 over 8. So again, I'm going to say my line in math is always pick your poison. I'm going to say you guys can use whatever method you feel is best for you, but I will tell you that my first way of showing you is my preferred. I also like the last way I just showed you guys because it does save a lot of time, but you have to be able to do that quickly in your head. You can't sit there for 4 or 5 minutes thinking about, what number can I multiply by to make it a perfect square? Okay, so any questions on the last slide before I model 3 more problems and then you guys try? And then all we have to do is 1 more type. Okay. So for the last type of question, and by the way, what I think I'll do for you guys tomorrow is I do have a homework assignment for this that I'm not going to give, but what I will do is I will work the questions out and then I'll post it. So it will say like extra problems. I'll probably do that in the morning and then post it by like the mid-morning to afternoon. If I don't get to do that by tomorrow, it'll be up. No, I'll do it tomorrow because you'd want it for Wednesday. So I'll do that tomorrow morning. I'll remember to do that for you guys. So the last 3 problems I'm going to model, in this case, these are both under the radical, but unlike the first set of questions, you cannot simplify these by dividing them evenly. So what you can do is you can separate them into 2 separate radicals and then simplify if you can. Now, remember the rule is we're not allowed to have a radical in the denominator. So I will rationalize if I can't simplify first. and I get radical 6 over 6. In letter F, 13 divided by 7 is not going to be even. So I will get radical 13 over radical 7. Again, I cannot simplify the denominator's radical. So I will rationalize right away. 13 times 7 is going to give me the square root of 91 over 7, and the square root of 91 does not contain any perfect square. So we will leave it as is. And then the same deal with G, we have radical 7 over radical 12. Now you could rationalize right away, or the square root of 12 can be simplified first, and you know this is my preferred method. I can then rationalize using radical 3. I would get radical 21 over 2 times 3, which is 6. And I get radical 21 over 6. Okay, so there it is for you guys to take into account. I'm going to give you guys 3, 4, 5, 6, 7 problems to try without me now. I'm really going to only put up 5 minutes because I do want to make sure that we are careful with the simplifying and all of that. Okay, so here it is. I'm open for questions if you guys have. 5 minutes on the clock, and try to think about a way that you guys like. I'm just going to check out one thing. I'm going to come right back to this. Sorry, I'm going to scroll right back. I'm just making sure my notes match up. Okay. Oh, sorry, here it is. Okay, so you're about 2 minutes in. Should be on like C or D by now at that point. Okay, so you guys are about 3 minutes in, so we'll give it another 2. And then we have one more topic that we have to cover. This went real nice tonight, guys. Thank you. Okay, so about 1 minute to go. For letter D, I'm going to show you 3 different ways one last time. Okay, so getting going on A, we cannot simplify the denominator, so we rationalize right away. Radical 5 over 5. For B, we cannot simplify, so again, we rationalize right away. 5 radical 3 over 3. For letter C, same deal, we cannot rationalize right away. So radical 15 over 15, radical 15 is going to give us 5 radical 15 over 15. The 5 and the 15 can reduce to a 1 and a 3. Again, you cannot cross into the radical. So you should have got radical 15 over 3. I'm going to do D last. So I'm going to go to E, F, and G right now. I'll do D at the end. So again, radical 3 over radical 4. Luckily for us, radical 4 happened to be a perfect square, so it's 2. For F, we have radical 12 over radical 5. You could simplify the radical 12 first if you want. You can rationalize first if you want. We get radical 60 over 5. 60 happens to have a perfect square of 4. So I get 2 radical 15 over 5. And again, if you went a different route, as long as you do the same thing, or excuse me, as long as you get the same answer, I should say, you're in good shape there. And then lastly, we have radical 9 over radical 11. So this is what I'm talking about. This can be 3 over radical 11. You can make it a 99 and then simplify, and you're going to get 3 radical 11 over 11. Finally, I saved D for last. So one last time, I'm going to show you the 3 methods, starting with my preferred method of simplifying first. So we get 10 over 2 radical 2. Rationalize with the radical 2. We get 10 radical 2 over 4, with the 10 and the 4 reducing to a 5 and a 2. Okay, so that's method number 1. Method number 2 would be to rationalize first. So we would multiply top and bottom by radical 8. 10 radical 8 over 8. The radical 8 would simplify to radical 4 and radical 2. We would get 20 radical 2 over 8. And of course, reducing by 4, we get 5 radical 2 over 2. Okay. And then finally, we're going to get, we're going to multiply the top and bottom by radical 2. This is to create a perfect square, which would be 16. We get 10 radical 2 over 4, which reduces to 5 radical 2 over 2. Okay, I'm not saying you have to do all 3 ways. That's ridiculous, but I just like to pose all 3 ways. Okay, so that's the second part. If anyone needs me for any questions, and then we're going to go into our last part, which is to rationalize binomial denominators. What I'll do is, I think I have, I'll scroll right back up. I have 6 problems to show you. We'll see if we're going to do all these. I might just work out the rest for you. We'll see how the time was. And anyway, so we'll go from there. Okay, so let me scroll back up for one moment to the beginning where I crossed that out. It says when we have a binomial denominator, we are going to, so this is always the case, we are going to multiply the numerator and denominator by the conjugate. Remember, the conjugate is the same binomial, opposite sign. So for this example, we are going to multiply the top and bottom by the conjugate. And let me explain the reason why. If we attempt to multiply by just the radical 2, when we distribute, we will not get rid of the radical. So the rule is anytime it's a binomial, use the conjugate. So I'm going to go through these examples for you. I'm going to try to do them at a somewhat decent speed so I can give you guys some time to try. So let's kind of see how we feel as we go. D, E, and F are a little bit more intense because they have binomials top and bottom, but we always use the conjugate of the denominator. So we're going to use parentheses around our binomials. Now, let me explain that in the numerator, we will distribute. So we get 6 plus 3 radical 2. And now remember, in a conjugate pair, the middle terms cancel. So we only need to multiply the first terms and the last terms. And we get 6 plus 3 radical 2 over 2. 2 is a rational denominator, so we're in good shape. Okay, and I'm just going to pause for a moment there. For B, you're going to use the conjugate. So again, the conjugate here is going to be radical 3 plus 2. It's just the same binomial with the opposite sign. In the numerator, when we distribute, we just get 3 plus radical 2. In the denominator, the radical 3's give me 3's. The 2's give me 4's. I get 3 plus radical 2 over -1. And that is going to give me, sorry, I just had an error in my answer, sorry. That is going to give me, now you can leave it like that, but you can also simplify by dividing the top and bottom. So -3 divided by, 3 divided by -1 is going to be -3, and radical 2 divided by -1 is going to be radical 2. And yes, that would probably be what you would see on an exam. Let me do C, and then I'll pause if anyone needs any clarification. So the conjugate here would be 5 radical 5 plus 3, radical 5 plus 3. So when we distribute, we get 2 radical 5 plus 6. In the denominator, we get 5 minus 9. 2 radical 5 plus 6 over -4. Now, if the coefficients 2, 6, and 4, well, -4, have a value in common, you must reduce by that value. The common value here is going to be, I must have been like really tired when I wrote my answer keys. I have some errors in my answer keys, but that's fine. You're going to divide everything by 2. So 2 divided by 2 is 2. 6 divided by 2 is 3. And 4 divided by 2 is 2, and it will stay negative. Okay, so let me pause there for you guys. If anyone has any questions, then I'll do the next 3. Julia?
Yeah, hi. So in B, I do believe there is a mixed up of radicals on the top. It's radical 3 plus 2.
Yeah, that's me being tired. There you go. So it's radical 3 plus 2. Thank you. Let me fix that all up.
Thank
So
you.
this would be, no, that's me. Negative radical 3 minus 2. Sabrina, is that the same question?
Hi, Professor. No, can you just go over B again? And
Yeah, let me
C,
do B
please?
again because I made some errors there. That's my fault. All right, let me do
Okay.
B one more time. And then if
Thank
anyone
you.
else- no, that's me. Okay, so starting from the beginning, we're gonna do, you're welcome. We're gonna do radical 3 plus 2, radical 3 plus 2. Those are our conjugates. Okay, so in the numerator, we get radical 3 plus 2. And in the denominator, you know what, I'm looking at my answers, which are wrong there. In the denominator, we're gonna get radical 3 times radical 3, which is 3. Radical 2 times 2, which is 4. So we get 3 under the radical plus 2 over -1. The radical 3 divided by -1 is negative radical 3. And the 2 divided by -1 is -2. Is that better?
Yes, thank you.
You're welcome. Anyone else for me? Okay, Nothing will change in D, E, and F.
Professor,
Yeah,
sorry, for B, what is the answer? Is that
it's
negative?
negative radical 3 minus. 2.
Okay.
Yeah, it's
Just
kind of
wanna make-
switched, so I'll write it there. Yep, no problem. I'll actually write an arrow and I'll erase that so you guys can see it a little better. Sorry about that. Okay, for D, E, and F, same deal, only you're going to use the conjugate, but you're gonna have to be careful in your numerator. So I'm gonna slow down a little bit here. Remember, it's the conjugate of the denominator. So it's 8 minus radical 6 because the denominator is 8 plus radical 6. Now in the numerator, you're gonna have to use FOIL. So 8 times 8 is 64. Minus 8 radical 6, minus 8 radical 6, plus 6, all over. Now the conjugates, we only have to multiply the first and the last terms. So it's going to be 64 minus 6. Now we're going to combine our like terms. So in the numerator, we're going to get 72 minus 16 radical 6 over 58. 72, 16, and 58 all have a common value of 2. 72 divided by 2 is going to be 36. 16 divided by 2 is 8. And 58 divided by 2 is going to be 29. And that would be our final answer. I'm just going to move it up slightly, but I'm definitely going to pause for you guys there. So again, you're using the conjugate of the denominator, but you are then going to make sure that you apply the distributive property. And in the denominator conjugate pair, you can multiply the first and the last terms, ignoring the middle terms. I'm definitely not going to have enough room to squeeze G in there. So what I'm going to do is I'm going to do G right here. So we're going to have 2 minus radical 3 over 1 plus radical 3. So we will use the conjugate of the denominator, which is 1 minus radical 3. Okay. So starting from the distributive property, 2 minus 2 radical 3 minus radical 3 plus 3 all over 1 minus 3. The 3 and the 2 will combine to a 5. The negative 2 radical 3 minus a radical 3 will give me negative 3 radical 3. I should really make that neater. So minus 3 radical 3. And in the denominator, we have a negative 2. 5, 3, and negative 2 have nothing in common. So you would leave it as is. Okay, and I'll do F somewhere as well for you guys. So I guess I wrote E, it's G, it's E. Sorry, I wrote G. For F, same deal. And then you guys are going to do these 5 problems. So we're going to multiply top and bottom by the conjugate of the denominator, which is radical 10 minus radical 2. Here we go. So radical 10 and radical 10 is 10. Minus radical 20. Minus radical 20. Plus 2. All over 10 minus 2. I get 12 minus 2 radical 20 over 8. Now I can simplify radical 20. So radical 20 has a largest square of radical 4. I'm going to get 12 minus 2 times 2, which is 4 radical 5 over 8. 12, 4, and 8 have 4 in common. 3 minus radical 5 over 2. So there's a lot of simplifying in letter F. So I will take questions. I know there are 5 questions here and it is already 9:30, so I just want to be cognizant of the time. So I'm gonna just start a timer. Sabrina, give me one moment. I'll definitely get you. I may stop you guys in about 3 to 4 minutes to check on A, B, and C, but please feel free to go to D and E if you're ready. Just because of time, I'm gonna work out. No, you know what? We should be able to do that, so never mind. So you guys can work on these. I may want to give you one more problem. So I'm gonna add a last problem down here, which will be letter F. And that way you'll get exposed to one more of these. Right, because I think, oh, it's over here, actually. Okay, so you know what I'm gonna do, guys? Excuse me, I'm sorry. I'm gonna make letter F this one. Okay, and then what I'll do is the last examples that I don't do, I'm gonna work out for you guys. So this one I'll work out for you, and then I'll work the other two out that are on this last slide here. So ignore these. I'm gonna work the other two out for you that are on that slide. And then that way you can kind of check those, just because I don't think we're gonna have enough time. So please get started. I apologize. I'll start the timer now. Sabrina, go ahead.
Professor, so for F, right? I kind of got lost where it's,
So the
I
numerator,
think this,
the
the
numerator,
second part, I think.
okay, so the numerator is 10 minus radical 20 minus radical 20 plus 2. Are you with me on the numerator?
Yes.
Okay, so when we combine our like terms, we combine the 10 and the 2 to give us 12. And then the 2 radical 20s to give us negative 2 radical 20. Good so far there?
I'm sorry, can you repeat that one more time? Sorry.
So the 10, that's okay, the 10 and the 2 would combine to a 12. And then minus 2 radical 20.
Okay, where that, I think that's where I'm getting confused. Where is the 2 coming from?
2 comes from the fact that you have imaginary ones as your coefficients.
Okay, thank you.
It's all right, sometimes it's hard to see. Is that where you were tripped up?
Yes, that was the part. Okay, I'm clear now. Thank you.
Got it. And of course, anyone else? I'm just gonna stop every few to check on you guys. So you can continue to do what you're doing. I am gonna slide off this screen for a minute to work out the other questions that we're not gonna have time to do together. I just know it's gonna get a little late. So what I will do is I will work them out. You can take a picture or you can download this when I post it. Okay, so I'll just work out G and H, G and H, not I. I'll slide back up once I'm done with these two. Okay, so as soon as I'm done with H, I'm gonna just check on you with A and B. It's not my traditional way of giving you guys time, but I want to ensure that we do at least check on you. Okay, and again, I can post that for you guys after. So if you didn't get it now, don't worry about it. All right, I'm just gonna check on A and B. By now, you guys should kind of be done with A and B. So the conjugate would be 6 minus radical 3. Okay, so we're gonna get 60 minus 10 radical 3 over 36 minus 3. This will give me 60 minus 10 radical 3 over 33. And there is nothing that is common to 60, 10, and 33. So that should be our final answer. Okay, for letter B, which I'll squeeze in here. I know this is going to get a little out of hand here, but I'll do the best in organizing this for you guys. So you know what I'll do for C, D, and E? We'll do them on the next slide. So we're going to have 3, 9 minus radical 5. So the conjugate would be 9 plus radical 5. Negative 27 minus 3 radical 5 over 81 minus 5. This is going to give us negative 27 minus 3 radical 5 over 76. I don't believe there is anything in common. 76 is not divisible by 3, right? I'm pretty sure it is not. Now, so we are done there. Okay, so I'll give you guys a little more time to work on the other 4 problems. I'm going to probably stop you soon for C and D, but if anyone has questions on A and B, feel free to ask. Okay, I'm just going to leave this here. I am going to have to go on a new slide for these. I really am running out of space. So I'm going to do C, D, and E and F over here. So here is the letter C. Conjugate would be 3 plus radical 2. We're going to get 18 plus 6 radical 2 over 9 minus 2. 18 plus 6 radical 2 over 7 with no reducing possible. Sorry. Okay, for D, the conjugate would be 4 minus radical 14. Again, when using the distributive property, we get 28 minus 7 radical 14 over 16 minus 14. That's 28 minus 7 radical 14 over 2. Again, 28, 7, and 2, they all have to have something in common and they don't. I'll rewrite F, I forgot about it. Well, it's actually H, but I made it F. Okay, so these are our last 2 problems of the evening. I will work out the questions on the division for you guys and post it. The conjugate for the next problem would be 3 plus radical 5. You might want parentheses. So that's 21 plus 7 radical 5 plus 3 radical 5 plus 5 over, again, the first terms and the last terms. The 21 and the 5 will combine to a 26 plus 10 radical 5 over 4. 26, 10, and 4 have 2 in common. So when dividing those coefficients by 2, we get 13 plus 5 radical 5 over 2. And then you guys can finish up with F, and then I can, again, if you, after that are good and you want to go, I will post the other questions worked out for you in the morning, most likely. And of course, you guys also have this that you can try and then, you know, compare. So I'll give you another few moments on F. So checking on you on F, we get radical 12 plus radical 2. Remember, it's always the conjugate of the denominator to make the rational. We get the square root of 36 plus the square root of 6 plus the square root of 24 plus the square root of 4, which is 2, all over 12 minus 2 in the denominator, because the radicals will just cancel on us. Sorry about that. We get 6 plus radical 6 plus radical 4 times radical 6 plus 2 over 10. So the 6 and the 2 will combine to an 8. The 1 radical 6, which is right here, plus the 2 radical 6 will give me a 3 radical 6 over 10. And that should be our final answer there. Okay, so just to reiterate what we discussed tonight, we went over when we have radicals in the numerator and denominator, if we can reduce, we would do that first, simplifying, of course, at the end. If we cannot, we will rationalize using the radical part in the denominator. Simplifying first is always a suggestion. And then if you have a binomial denominator, we use the conjugate. So I know some of you guys like to hop off, so I don't want to keep anyone that doesn't want to stay. These are the notes for tonight in terms of our problems. I'll put these up now. If anyone wants to take a quick screenshot, or if you want to actually write them down or whatever. I mean, I will post this anyway. Your exam will cover this material. So in the morning, I'll post the answer key to this. I will post the video. And I will also work out the homework that I was going to give for extra practice. So you can definitely go through those. And that's really it. So if you don't need me, please remember, guys, you need to upload your work within 45 minutes of the exam completing. So we get ready for a final doing that. Some of you I've reached out that your stuff is not uploading correctly. So please just fix that. If anyone does need me for anything, systematically, I'd like to go in order. So if you can just raise your hands, it would keep things a little organized. And if you don't need me and you're just hanging on, you can hang on or you can leave. It is entirely up to you. I always thank you guys for a great night. I was just like talking about you as a class, and you're really just a really nice class to have, especially on a online platform. So thank you for your time. Again, if anyone does need me, please feel free to ask anything you might need.
Professor, can you please scroll up to A through E?
For this section, yes. Now remember, A through E was not all done on here. I did them on a separate page.
Okay.
So if you need me to move down, just let me know.
Okay, thank you.
You're welcome.
Have a good night, Professor.
Good night, guys.
No, imagine.
Chris, go ahead. I'm just gonna mute you if you're not.
Have a
just-
good night, Professor.
Guys, you too.
Out of 3 years.
Sorry. Christopher? All right, no response.
Professor,
Hey, what's up?
can you go back to letter H, the last question that we did?
I absolutely can. Let me just keep this up another moment. Guys, remember, I'm happy to scroll around, but you're all kind of on different pages. So if you can't get it now, remember that I will post this so you don't have to worry so much. I mean, I'm not telling you I won't scroll, but you're all kind of different spots. But the oh, my screen, this does this every single time. All right, for some reason, my screen is not scrolling, so you're gonna have to give me a minute. If you can wait, then I'd appreciate it. If not, I gotta re-sign onto Zoom. It seems to do this every night to me at this time. So just give me a moment. But if you want to wait, that's fine. And Zelha, you can ask your question while I re-sign on if you'd like.
Yeah, I was wondering in letter D.
Okay, I'm gonna have to get back on, so you gotta give me one moment, okay? Just sorry, this thing is just a real pain lately. I don't know why. Let's see if it works now. Yes. Every single time the last few nights it's done this. You guys are seeing my screen's frozen still. All right, try to ask me your question.